Okay, hello everyone, this is Santiago Arias. Today I'm going to do a presentation about an article that is called To Do in 21, Get Up to Speed with Quantum Computing 101 for the Computing Principles for Programmers class. Okay, so the first step is to understand that quantum computing is actually evolving really fast. Some people don't realize this, but it's advancing a lot faster than expected. Okay, so a quantum volume is the measurement overall of how we can measure the power of a computing quantum machine. Also, quantum computing is approaching a point where it will be able to help many businesses and achieve big things in the tech industry and many more industries. Okay, so the basics of quantum computing. Linear algebra is the language of quantum computing. It's also helpful to understand a little bit of quantum mechanics, and also researchers and developers use linear algebra to describe qubits, states, and quantum operations. This way, we can actually predict how quantum computing will behave when it's presented with a problem or any operation that it has to perform. All right, what's a qubit? Qubit, it's basically the most basic form in quantum computing. In regular computers, we have ones and zeros, right? The qubits are the ones and zero of quantum computing. Managing these items can be very challenging. Some companies use supercooled circuits, others trap individual atoms in electromagnetic fields on a silicon chip in ultra-high vacuum chambers. Okay, quantum entanglement. Particles that are entangled have behaved the exact same way. It's like they're the same. Just that they don't. Actually, they only behave the same. And when you do this with a quantum computer, you can actually double the power and they will behave exactly the same as if they were working on their own. Okay, superposition. This describes the combination of two states that are normally independent. Qubits can also be in more than one state at a time, so they can be 1 and 0. This is why it's so hard to work with them. And superposition allows us and allows quantum computers to consider many possibilities at once. Because of this, that I mentioned before, that they have more than one state at the same time. Okay, final thoughts on this on these quantum computing stuff right now. So the current challenge with quantum computers is keeping the qubits stable for long enough time that they can complete a calculation, right? Even though they have a lot of power, we have not been able to achieve this. Qubits can sense each other and they operate, and heat and radiation can affect them. So this can cause very, very hard errors. For example, augmenting training data, they can improve the ability of machine learning to detect concerns and rare events, such as pandemics. And Smith Godson compared the frequency of errors of a laptop. Regular computers have one error in every trillion of operations, and the frequency of error in quantum computers is 100 or 200 operations. Okay, right, this is where the article is coming from. Thank you so much.